All right, this is section 3.2. This is linear equations in two variables. So, sorry, I'm having a little tech hiccup. When we talk about linear equations in two variables, we're talking about something a little different than we were in chapter 2. We're talking about equations that set up more like ax plus by. Sorry, my phone is trying to get involved in our live or my recording here. Let me just fix that. Okay, so when we see, this is what we call standard form here. Okay, this is two variables. There's an x and a y, just like there was on the coordinate plane. That's why we're talking about this here. So when we talk about a linear equation of two variables, the first thing that we can do is see if ordered pairs are solutions to them. So remember that ordered pairs, there's an x coordinate and a y coordinate. It's handy because in my equation, I have an x and a y. All I'm gonna do is replace x for x and y for y. So I'm gonna get 6, I'm gonna put 2 in for x. Oh, sorry, I should be a minus sign. Minus 5 times 0 equals 12. If this comes out to be true, 12 minus 0 equals 12, check, that's accurate, then yes, this is a solution. Let's try the second one. We're going to replace the same way. 6 times 3 minus 5 times 1. Let's see, that's 18 minus 5. 18 minus 5 is 13, not 12. So that's a no. I'm going to put a no there. And then we can try the third one. Let me pick a different color and do the same work. So 6 times 1 minus 5 times negative 6/5. Don't freak out. Watch what's going to happen. Equals 12. So 6 times 1 is 6. These two 5s cancel. Negative and negative makes positive. 6 plus 6 is 12. So that's a yes. Here's the thing. You need to tell me when you do this work on paper or on a test that you know which ones are yeses and nos. Don't make me guess. Show me. Okay? You try the next ones on your own. Okay? Pause. Take a look through. I will tell you the first one should be no. The second one should be yes. And the third one should be yes. If you get stuck, if you're not sure, if you can't figure out why that worked, come into the chat. Let's talk about it. Okay? Or the discussion. Why do I say that all the time? So let's now move towards graphing. We know how to see if something's a solution. The graph of an equation in two variables is the graph of all ordered pair solutions to the equation. So basically what this says is when I make a graph, it's all the ordered pair solutions, just like this, that would have made this equation true. So these 2 points would be on the graph of that line. But this one, 4, 0, would not be. So let's try one. We want to graph x minus 2y equals 8. When we do that, one of the options that you'll use a lot is to make a chart. And really, I'm just going to pick numbers for x and figure out y. So let's say I pick negative 2. Well, if x is negative 2, I'm going to fill that in. X is negative 2 minus 2y equals 8 plus 2 and solve for y. So I get negative 2y equals 8. Divided by negative 2. Y equals negative 4. So when x is negative 2, y is negative 4. I'm going to pick the next number. Maybe I'm going to pick 0. So let's choose 0. So let me give myself some space. All right. When x is 0 minus 2y equals 8. And here's the thing, I'm just picking numbers that I think that would make sense. I'm just trying some things. So if that's 0, all I have to do here is divide by negative 2. Y is, oops, sorry, the last one I added wrong. Shoot. This is negative 4. The last one I added 2 to both sides. Should have been negative 5. Oh, good Lord. Sorry, guys. You're probably thinking I'm crazy because I didn't add. Okay, so, and then I'm going to pick another number. An equation of a line is never, ever, 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 ever made with less than 3 points. You need 3 points to make sure you did it right. If I just did these two and one of them was wrong, I wouldn't be able to tell when I screwed it up. But if I do 3, I can see my mistake. So always do 3, won't kill you. So I'm also gonna pick, let's say x is 2. So if I put in 2 for x, minus 2y equals 8, minus 2 to both sides, negative 2y equals 6, divide by negative 2, I get y is negative 3. All right. So now I have these 3 points. So when x is negative 2, y is 3, 4. Oh, sorry. X is negative 2, y is negative 5. When x is 0, y is negative 4. And when x is 2, y is negative 3. See all these points line up. If one of them is wrong, it would have looked funny. It wouldn't make a straight line. All of these equations are linear equations. They should make a straight line. The nice thing is, if it doesn't make a straight line, you're doing something wrong. You'll be able to see it. Let's try another one. So you're going to make a chart, x, y. You're going to choose some values for x. Pick things that are going to work easy. I tend to negative 2, 0, and 2. This is just me. So I'm going to put in negative 2 for x. 2 times negative 2 plus y equals 6. This is negative 4 plus y equals 6. So plus 4 to both sides. Y is 10. Okay. For 0, 2x, 2 times 0 plus y equals 6. That's just going to be 0. So in this case, y is going to be 6. And then for positive 2, it's 2 times 2 plus y equals 6. So that's 4 plus y minus 4 to both sides. Y is going to be 2. Okay, and now I can graph. Well, that's a 6. It's a terrible looking 6. So when x is negative 2, y is 10. Why don't we make that 2, 4, 6, 8, 10 on the y-axis so we can make this look okay. So when it's negative 2, this is up here at 10. When it's 0, it's up here at 6. And when it's 2, it's over here at 2. And I make a straight line. All right, you try the next couple. This is the idea. Okay, and this one, I chose some different points. Really experiment. It's okay to pick 3 numbers and then pick 2 other ones. Pick what you want. Pick something reasonable. Okay, in this case, I chose 3, 0, and negative 3. When I put them in the equation and solve them, I have 1, 5, and 9. So your line looks something like 3, let's see, positive 3 and 1. 0 and 5. Oh, sorry, that's not 5. An eraser. 0 and 5, and 9 would be way up here, so it's sort of a straight line this way. Okay. And then this last one has a fraction in it. You will not die, but let's look at it together. So I'm going to pick things that will make the fraction go away. So just like the last one, I'm going to pick things that are multiples of 3. I'm going to pick 3, 0, and negative 3. So I'm going to fill in at least one of these and show you what happens. So I get y equals negative 1/3 times 3 plus 1. Well, those 3's cancel, so I get y equals negative 1 plus 1. That makes 0. When I try 0, y equals 1/3, negative 1/3 times 0 plus 1. Well, that makes 0, so y is just 1. And then when I put y equals negative 1/3 times negative 3 plus 1, these 3's cancel, and the negatives cancel, so I just get 1 plus 1 is 2. And then I can graph. So at x is 3, y is 0, so x is 3, y is 0 here. At x is 0, y is 1, and at x is negative 3, it's 2. So here's our line. This should be pretty familiar. You've done this before, okay? So an x-intercept of the graph is the point a comma 0. where the graph intersects the x-axis. We just saw one of these. This is an x-intercept right here because the graph crosses the x-axis. The y-intercept is the point 0, b, where it intersects the y-axis. We just saw one of those in the slide too. Right here, I'm gonna put it in blue. That's the y-intercept. So that's the x-intercept. This is the y-intercept. These are pretty handy points for us to know. Okay, we can find them by substituting in. When we want to find the x-intercept where it crosses the x line, we put in y for 0, 0 for y. When we want to find the y-intercept, we put in 0 for x. So let's try that. I want to graph this equation. So what I'm going to do is I'm going to find the x-intercept. I'm going to find the y-intercept. I'm going to find one more point because we need 3, and then I'm going to graph. So the x-intercept is me putting in 0 for y, right? Isn't that what we just said? X-intercept, y equals 0. Okay, so I'm going to have negative 3x plus 2 times 0 equals 8. Negative 3x equals 8. X equals negative 3 over 8. I just divided both sides by negative 3. To find the y-intercept, so this point is going to be negative 3 over 8, comma 0. Right? Oh, negative 8 over 3. Oh, Sarah, pardon me. Negative 8 over 3. Good gravy. Got my numbers backwards. That's what I get when I try to write small. So, and then I'm going to do the y-intercept. So I'm going to put in x equals 0. So that's a negative 3 times 0 plus 2y equals 8. So that's, this disappears, 2y equals 8, y equals 4. So I'm going to get, the point here is 0, comma 4. And then I can pick one more thing. So maybe I want x to be, I don't know, let's call it 3. So when x equals 3, it would be negative 3 times 3 plus 2y equals 8. That makes negative 9 plus 2y equals 8. You can make it whatever you want. Add 9 to both sides. I get 2y equals 17. Nope. Yes. Divide by 2, y equals 17 over 2, which is roughly the same as like 8.5. And then you put it on the graph. So 8 over 3, comma 0 is like slightly less than 3, right? 8 over 3, comma 0 is around there. What am I? Negative 8 over 3. Pardon me. I missed a negative. Negative 8 over 3 is right over here. The next one is 0, comma 4. So that is up here. And then I picked 3. So it was 3 and somewhere way up here, like, what was it, like 8.5. And that makes the trend about right. So we draw our graph. Sorry, terrible line. You get the idea. You try the next one. Substitute in 0 for where you see x to get the y-intercept, 0 where you see y to get the x-intercept. Pick another point. Okay, I will tell you that for these, the x-intercept should be negative 4, comma 0. The y-intercept should be 0, 4 over 3. And you can be able to graph from there. Okay. All right, a couple more like this. Same idea. X-intercept, y-intercept, move on. So in this case, I'm going to put in the x-intercept. I'm going to put 0 in for y. I get 4x plus 5 times 0 equals 0. I get 4x plus 0 equals 0. I divide by 4. X is going to be 0. So it's 0, 0. For the y-intercept, 4 times 0 plus 5y equals 0. I'm going to get divide both sides by 5. Y is also going to equal 0. So here's the thing. At this point, both the x-intercept and the y-intercept are the same. They're here at the origin. That means I need to find 2 more points because I can't make a graph out of that. So pick a couple numbers that you want to fill in for the graph. You could pick, I don't know, let's see, whatever you like. Let's pick 1 or 2. Let's pick x is 2. So if x is 2, 4 times 2 is 8. Well, let's write, let's make some space. These slides are so small. I'm out of room. So if x is 2, 4 times 2 is 8, plus 5y equals 0. I'm going to subtract 8 from both sides. So I get 5y equals negative 8. Divide by 5. Y equals negative 8 over 5. It's like between 1 and 2. And maybe I'll pick negative 1. I don't know. 4 times negative 1 plus 5y. That's negative 4. I'm going to move that to the other side by addition, right? So I get 5y equals negative 4. That ends up being y equals negative 4 over 5, which is just a little smaller than 1. So at 2, it's a little, not quite 2. Up here somewhere. Oh, my dot's off. And at negative 1, it's like a little less than 1. So that's kind of what that line looks like. Keep going, and you just keep practicing. In this case, this one is going to work out very similarly. The x-intercept here and the y-intercept should both be 0, 0. So then find some additional points and plot them, see what it looks like. The last 2 things in this section are equations of vertical and horizontal lines. A vertical line, remember vertical is up and down, the way you stand, is represented where x equals k and k is a constant. So a vertical line this way is something like x equals 3. What it means is that x equals 3 no matter what the y value is. So for every point, x is 3. And I can put any y I want and put it in, and that'll make a line. A horizontal line, where you get the horizon like you lay down on the ground, is represented by y equals k. So y equals 3. This is a horizontal line where k is constant. So in this case, the point I'm making is something, comma 3. Any x value, y would still be 3. Okay, that's what this says. Oh, I'm making points somehow. Yikes. All right, so y equals 3. Oh, interesting. Any x value, y equals 3. This is just going to be y equals 3 no matter what the x is. So it looks like this. It's a horizontal line at 3 through the y-axis. For y equals negative 2, same idea. It's just y equals negative 2 no matter what the x is. So it's a horizontal line at negative 2. For this one, this is going to end up being a horizontal line. We just don't know it yet. Or a vertical line. No. Vertical line. Sorry, this is a bad word there. Divide both sides, get x by itself. I get x equals negative 2. So what that says is x is negative 2 no matter what the value of y is. So for every value of y, x is negative 2. Vertical line at x is negative 2. The last one, do the same thing. Get x alone. X is 4. Vertical line at x is 4 for every y value. So when you're graphing linear equations and you only see one variable, that tells you it's going to be a horizontal or a vertical line. That's the clue. If you see both variables, odds are it is some sort of other thing, right? It's some sort of other line. All right, this is the end of 3.2. Go on into the module, do what's next. See you there. Ask questions if you have them.